Greetings, Object Coder. I'm getting started with linked list. Let's jump right to it. We recently did dynamic array, right? Getting started with dynamic array or the solutions for the 30% on dynamic array. So we're going to actually reuse the test for that actually as is. We won't even have to change them except for the name dynamic array. So let's do a search and replace. This is the test for dynamic array, if you recall. I renamed it to linked list test, file name. And let's do a search and replace on dynamic array and linked list. Get linked list in there and do replace all. There we go. We don't have any errors in this class now. Now let's give it a run. And otherwise, we've copied the project template in for this project, and that gives us a linked list class with all the headers basically here and a whole bunch of to-do tags, right? That is the project template. So let's give that a run, our tests. And this is a thing of beauty to me. This is our to-do list. So this gives me some confidence that we can now work. Otherwise, just kind of, I feel like I'm just hacking away. Hacking away. Don't really know. If we've got it right or not. And that is the beauty of it. So let's just make sure I didn't. Okay. So we have a bunch of tests here and a bunch of failures, and those failures are because we haven't coded yet, right? So as usual, we want to understand what we're coding. So that would be in our linked list in the logic area of linked list, the chapter right before the challenge, and we can learn about things such as how we traverse a linked list, the design, things like that. Let's take a look at the design, huh? All right. So here's the linked list. Look at this object. It's very simple, isn't it? How many ibars do we have? 1, 2, 3. 3 ibars. We point to the first node, the last node, and we track the size. It's a housekeeping node there. Now you notice that we could have a couple more, or we could have a million or a billion or a trillion, whatever, nodes in between this first node and last node. But this is all we have to think about in terms of being a linked list. So that is what size 1 looks like here if we have one node. And remember, these nodes hold data. So they hold, in this case here, they're holding in this little picture, they're holding city objects. So Brooklyn Park, Robbinsdale, Golden Valley, they're holding city objects, but they can hold whatever, employees, customers, whatever. All right, so there's one, size of 1, size of many. Here's size of many. But again, remember, from the context of linked list, we're just thinking about first node and last node and size. So that's our object diagram, which we've already talked about. Let's take a look then at the important element there, what we talked about, that node. Remember, it's all about these nodes, all about these node guys. Let's take a look at what the node might look like. So the node fundamentally has data. It hangs on the data. Could be an employee, could be a customer, could be a planet, could be a song, whatever, some piece of data. That's what the node hangs on to. And also it holds on to the next node and it holds on to the previous node. So that's all a node is. A very, very nice. Here's a node with person data. Here's a node with a city data. All right, so that's a node. Alrighty, so, and here's our object diagram. All right, I think we're ready to start doing a little bit of coding here, I would say. The node itself, as we just looked at, very simple data, type T, so we can vary that data. It might be city, might be employee, might be customer. That's going to be the T, city, employee, customer, song, etc. And then the previous node, next node. And all we need there really is one constructor on the data, and then we just need getters and setters. Standard. This is a very simple class. All right, so we go into our linked list. And in our linked list, again, because of those pictures we were looking at, or because of our understanding, I should say, remember our understanding here is that we have a nice simple class with a first node and a last node and a size. Here we go, our first node and last node and our size. So of course, for this to do here, all we have to do is return the size because we have it in hand, right? And it's empty. If you recall dynamic array, we can just reuse size, return this size. For the empty case, it would be what? 0, right? No elements. Let's go rerun our tests. I can't wait to rerun tests after I code. I want to see how I'm doing. We get a pass, we get a pass. We're passing a test already. That's pretty good. We're not passing one with a size 1 test case. Well, that makes sense. We haven't coded the add type functionality in yet. Let's just code in a very simple part of the add functionality. I don't want to ruin all your fun, but let's just do a little bit here. And if we go to the algorithms and look at adding the first node, really all we're doing is we construct a node and we set the first node and the last node to that node. And that node is going to have initially the next node and previous node to null, right? Because there is no next node, there is no previous node. That's the only node for the first node case. So let's code that up. Actually, let me see if there actually is code for that. All right, let's code that up. So let's go into linked list and we want to go to the add method, right? We want add to work if we want some of our functionality to work. And if you recall, this was also similar in dynamic array, and hint, hint, superclass possibility here between dynamic array and linked list. We won't do that here. It's optional. You don't have to do it. Just because explicit things are a little bit simpler to understand as we're learning. So we'll keep it explicit. This add last, if you remember, it's an alias. It's an alias there. It says it right there, alias. All right. Now we're going to go to add last. So what do we do when we add data? This is data, type E, right? That is data. What are we really doing when we're adding? We're actually adding the data, of course, but we're actually adding that node that wraps the data, right? So let's use helper methods again. We love our helper methods. This, let's do, I think, let's say here. Let's do this add last node instead of, okay, and then this will construct a node given the data. So we actually have two helper methods here, right? One method is going to construct a new node and one is going to add a last node. All right, let's put those in. I'll put them in as private. Doesn't really matter too much, but void new node. First we'll do that. And e new element. So we return I called my node a DL node, doubly linked node. New DL node with the new element or the new data, we could call it also if we wanted to, if that made more sense to us. Sure, change our variable names. Always coder's choice, variable names. All right. New deal the node, and what are we getting there for an error? Deal node is a raw type. Okay. Void methods cannot return a value. Very good, very good. Very true. DL node of type E. There we go. All right, we have that one going. We have one more here to put into place, and that is add last node, private. And I think that one can be actually void add last node, and the argument there would actually be a DL node of type E and a new node. And if you recall from our little study here, that for the first node, again, all we're setting is the first and last node. That's all we really have to do. So nice and simple. And we'll set the size too. But we have to check for this case here. Okay, so if this is empty, that's the case where we're going to add our first node, right? That's the first node case. Then we would just say first node equals this new node. This last node also equals the new node, right? Because it's the only node, right? And we know in this case, because that the size is going to be, and let me just think about something here for a second. Let's increase the size and let's return. And let's put a to-do tag here so we don't forget that if we're not the empty case, we're going to hit this. So we're actually going to need to do some work there. Let's see what happens when we run our test again. I can't wait to run tests after I go. We got to pass. We got to pass. So we're working along. And in this find first, I think we're adding 4 elements there, so that would definitely fail because we're only handling the size 1. So I think we're actually going to stop here. That gets you quite a long ways into the, I'll show you one other thing though. I do want to show you one other thing. But that gets us quite a ways into our coding actually. It gets us gives us some inertia. We're getting some very simple methods working. We're also getting the add mechanism, the fundamental, and obviously we can't do anything without the add mechanism. We're getting that kind of underway. I just want to show you iteration. Obviously iteration is hugely important in many of the methods we'll do here. And we can look under traversal here to see some iteration. Right here under traversal, traversing the nodes. So actually let's go back here for 1 sec, just to even think about it. If you think about this linked list and how it sits here, and let's go look at the one that's this one here. You can see that iteration would be, going to that node and then following these nodes, just following that pointer from node to node, and at each node we can get the data to iterate on. And then when we hit a null, when the next node is null, then we're done with our iteration, right? We can also iterate backwards using the previous link. And again, when that's null, we're done iterating. So let's take a look at traversal here and see what we have. We could look through that, get a good understanding of that, and you'll see here, really it all boils down to this. This is how we can iterate. Get that in a forward direction. Get the next node, and then while that next node is not null, do whatever we want to do, and then move the next node to the next node. Move this variable here to the next node, and keep going until we hit that null, and that loop will end. That's how we traverse. So that helps us get going, I think, and we will talk to you soon.